Welcome to an example of graphing a parabola, an x squared equation, where there's no parentheses. So what I want to make clear to you is that there's two kinds of x squared situations. So the first kind is when they give you something like y equals 3 parentheses x minus 2 squared plus 7. When they give you with parentheses, so this is the first kind. Let me just move this over and say type 1, sorry, I'm a little scribbly there, type 1, where they have parentheses squared. So there's two kinds, two types, I'll call it. Two types of x squareds. So the first type, type 1, we have parentheses squared. So if you have that, these are the easy ones. You just go opposite and same. So the opposite of negative 2 is positive 2. The same as plus 7 is just plus 7. And that will be the center of the U-shape, called the vertex of the parabola. That's the center. That's the most important point. So now that's type 1. Now that's not what we have. See, we don't have any parentheses squared. So there's other examples where you have parentheses squared in your formula, and that's great. Those are the easiest kind. Type 2 is where you have no parentheses squared. So that would be like our example now on this problem, y equals x squared plus 8x plus 12. There's no parentheses squared. So how are we going to do this problem? We can't just do opposite same, which was so quick and convenient for finding the center. We still have to find the center. It's still all about finding the center. How are we going to do it? Well, to find the center, it's much more work. You've got to use the formula x equals negative b over 2a. So this is the case 2 where there's no parentheses squared, which is our situation. So x is negative b over 2a. What do we mean by that? I think you know, but I'll put it in anyway. This is a is 1, b is 8. So negative b, negative 8 over 2 times a, 2 times 1. So x is negative 8 over 2, negative 4. So x is negative 4. So that's part of the deal. I'll go negative 4 comma, that's the x value. Now we need to find the y value. So now what you do is you plug in x equals negative 4 to the original formula. You just bring it down here. Y equals x squared plus 8x plus 12. And then you just plug in your negative 4. So I'm going to grab that negative 4 and I'm going to plug it in there for x and plug it in there for x. And I get y equals negative 4 squared plus 8 times negative 4 plus 12. So y is what? 16 minus 32 plus 12. I think that's minus 4, isn't it? Yeah. So y is minus 4. So coincidentally, the center, the x and the y are both the same. Negative 4 for x, negative 4 for y. So that's how you find the center. Now we got some more work to do, but that's the lion's share of the work. That's most of the work right there, is finding the center. Because once you have the center of the U-shape, let's go locate that. You're almost done graphing. The rest is the same as what we did before. I'll show you if you don't remember. And it's not too hard. So let's find it. Back 4, down 4, right there, huh? So back 4, down 4. There's the center of the U-shape. Okay, so and now that we have the center, how do we go from there? Well, we do just what we did before. We look in the front. What's in the front right there? Well, there's nothing in the front, right, which is the same as what number? 1, right? You put that over 1, so that becomes rise over run. So it's just like what we do with the parentheses. Like back over here on this one, if we're doing the parentheses, I'd put rise of 3 over run of 1. It's the same deal. So you go, so back in our case, rise is 1, run is 1. So I go from the center, go up 1, over 1, boom. And then it's symmetrical, so you go the other way also. There is our U shape. It goes from the center right up through those two dots. Did you see how we did that? So one more time. You look right in the front. If there's nothing in the front, it's 1. You put it over 1 and you treat it like a slope. Rise and run. That's from the center. So if this is positive, we're going to go up. If that rise was negative, I'm going to go down, and that'd be a U shape going down. So I rise up 1. I went up 1, and I went over 1 from the center. Up 1, over 1, put a dot, and then go the other direction also because it's symmetrical. And you have 2 other dots that your parabola goes through. So there we go. There we have the parabola graphed. And that's the same thing. Now, if there was a different, what if there was like a minus 2x squared plus 8x plus 12? What would I do? I would just put that over 1. That would be my rise over my run. And if my center, let's just make it right here. If my center was, whoops, I'm getting kind of scribbly there. If my center was right here, I would go what? Down 2 over 1. And then same thing other direction, symmetrical. That would be my U shape. Does that make sense? Whatever number's in front of x squared, just put that over a 1, treat it like a slope. That's your rise and run. If it's negative, you go down. So if the center was over here, I would go down 2 over 1, and then same thing other direction because it's symmetrical. So that's how we handle finding the other 2 points after we have the center. So the major part of the work was finding the center. All right, so let's put the information at the vertex. That's the -4, -4. That's the center. The Y-intercept. Now the way I drew it, it looks like it hits it 2, but I don't think that's really the truth. How do we actually find the Y-intercept? Let's come on down here. Let me do it right here. This is question 3. So Y-intercept. How do we find a Y-intercept on any graph? Right? It's some kind of point like this right here, right? Because this is the x-axis, this is the y-axis. You're wondering, where does your graph, whether it's a straight line, a U-shape, parabola, whatever, where does your graph go through the y-axis? Well, it's not 2. I mean, I just made that up. That's not really where it's at. But my point is, it's over 0 up something, isn't it? Its x-coordinate must be 0, right? If it's on the y-axis, its x-coordinate has to be 0. So that means when you're looking for a y-intercept, you set x to 0, or plug in x equals 0 to the equation. So you just grab the equation, y equals x squared plus 8x plus 12, our original equation, x squared plus 8x plus 12. And then you plug in 0 because at a y-intercept, x is 0, isn't it? At a y-intercept point, that means your x is 0. So what do you get? 0 plus 0 plus 12. So y is 12. So the y-intercept must be the point 0, 12. See where the 0 came from? Because that was the x. It's the x, and the y came out to be 12. So the point 0, 12. So the y-intercept is the point 0, 12. So I'm like terribly off. Let me try again in my graphing. So it's more like this. It's going to go 10, 11, 12. It's way up there. So it just rockets up. Boom. And same thing other side. Like that. All right. So there's the y-intercept up at 12. At the point 0, 12 is the y-intercept. How do we find the x-intercepts? Well, same thing. X-intercepts are like these points here. And notice if you're at those points, you're over, I don't know, up 0. Same thing here. Over, I don't know, up 0. Your xy, your xy, your y in both cases is 0 because if you're on the x-axis, this is the y-axis. If you're on the x-axis, then your height, your y height is 0. Right? So to find an x-intercept, we plug in or set y to 0. See how with intercept points you always make the opposite letter 0? So for a y-intercept we make x 0. For an x-intercept we make y 0 because that's what it means. That's what it means to be an intercept point, right? If you're here, then your height is 0. So your other letter is 0. All right, so let's take the same equation. Y equals x squared plus 8x plus 12, and I'm going to plug in right there 0. Okay, so now I need to solve that. Well, how do you solve that equation? Well, that one's actually factorable. X is in the front. We're looking for two numbers that multiply to be 12, add to be 8. What times what is 12? So it's 2 and 6, isn't it? They multiply to be 12, add to be 8. Then remember how you solve? When you have two things multiplying to equal 0, that means either one of them could be 0 to make that true, doesn't it? Do you understand that logic? I don't want to just say that and you just write down the steps. Think with me logically for a minute. If I said, hey, I'm thinking of two numbers, I'm multiplying them, and I'm getting the answer 0. How can that be? How can you multiply two things? How can you times two things and get an answer of 0? Well, one of them has to be 0, doesn't it? The first one could be 0 or the second one. If either one of those is 0, then when you times them, the answer will be 0. Well, that's what this is saying. It's saying something multiplied by something, right? These are parentheses. It means multiply, as you know. Something multiplied by something equals 0. So that means either the first one could be 0 or the second one. If either one of them is 0, they'll times to be 0. That's why that's true. Okay, let's keep on moving here. So then we just solve this equation. Subtract 2 from both sides. X is negative 2. Subtract 6 from both sides. X is negative 6. So negative 2 and negative 6. Those are the two, and they go with a 0. So negative 2, 0, and negative 6, 0, right? Because they both came, remember this all came from y equals 0. So the x is negative 2 and the y is 0, or the x is negative 6 and the y is 0. They both started with y becoming 0. So they go with a y, 0. So there they are. Let's go put them in there. Doesn't matter what order. So minus 2, 0, and minus 6, 0, or the other order around. Doesn't matter. All right, got the x-intercept. Let's go see if that's right on the graph. Yeah, look at that. Minus 2, 0. That looks right. The other one looks like I missed a little bit. Let me go back and kind of fix it after the fact. I'm kind of like cheating. Draw the, throw the dart first and then draw the target afterwards, kind of thing here. So minus 6, there it is. So boom, like that. That's more accurate. So yeah, these points are. Let me get rid of this one and get rid of this one and label them correctly. This is 2, 0 and minus 6, 0. Those are the x-intercepts where the U-shape goes through. Mine's looking a little wonky, but it's right. It's just my bad drawing. All right, domain and range. How do we do that? Well, remember what domain is? Domain is how far left and how far right. How far left and how far right the graph goes. That because domain is the x values. So the x-axis goes right and left. So how far left and right? Well, forever left and right, right? This graph goes up and left forever, and this graph goes up and right forever. So it goes left and right forever. So it's going to go from negative infinity to positive infinity. So the domain is negative infinity to positive infinity. And now, what's the range? The range of a graph is the up and down coverage, right? So the range is here. And it goes from the bottom. What's the bottom of the graph? What's the top of the graph? What's the lowest on the y-axis? So the range is all about the y-axis like the domain was all about the x-axis. The range is the y values. So what's the lowest this graph goes? What's the bottom of this graph? It's right here, isn't it? Negative 4. I marked over it. There we go. Negative 4. Up to what? Well, it goes up, up, and away, doesn't it? Infinity. So it goes from negative 4 to infinity. And we got to put a bracket at the negative 4. Right? Do you know the difference in that? A bracket means it hits negative 4 straight on. Right? It's not just close to negative 4. This point is negative 4 height. It hits it straight on, so it's a bracket there. And the parentheses on the infinity, because it just goes towards infinity. You're never straight on infinity. Finally, equation of the axis of symmetry, right here. That's just the line that goes through the middle. So, if I do this line right there, that's the axis of symmetry. It's the line, the symmetry line, the symmetrical line. It splits the graph. The graph is symmetrical. It's the same on both sides of that line. What's the equation of that line? Well, look, it goes through the x-axis at negative 4. So that's just simply x equals -4. So there we go. So the main point of this example was what we started with. Let me make sure that's clear. You have two types of x squared graphs. Type 1, there's parentheses squared. That's the easy kind. You just do opposite, same. The opposite of the number next to x, that'd be +2. Same as the number off to the right, +7. There's your center, away you go. But our example was type 2. No parentheses squared. So in that case, you got to use this formula. X equals -b/2a. Super important formula. Make sure you put that in your notes. Going to need it on the next exam. Very, very important. -b/2a. So you got to identify the b and the a and plug in -b/2a. Find your x value and then plug in that x value to the original formula and find your y value. And that's how you get the center of it. When, in that case, when there's no parentheses squared. That's how we get the xy center. Then once you got the center, you just use the number in the front, put it over 1, rise over run, right? And I found these 2 points. And then the x-intercept and y-intercept, that's by setting the opposite letter to 0. So there